In the last video, we talked about how you can read text files. Now let's look at how you can write with text files. So it's pretty straightforward. When you want to write in text files, you use the write function. We use the write function when we want to write single lines onto text files. So by default, the write function does not add a backslash n, which we call our end of line character into the file. But let's say we want to enter multiple lines in the file. Let's say we have 5, 6 lines that we want to enter. For that, we use the write lines function. So, how do we use them and what are things that we need to remember? Okay, first of all, your write lines function takes in a list as an input, whereas your write function takes in a string as an input. Now, the list which we use with the write lines function could look like anything. Essentially, what I want is each of my separate lines to be separate elements in the list. So, let's say my first line is hi, comma, my next line is bye. So, if this is my list and I use that in the write lines function, essentially these will be separate lines in the file. Whereas if I just want to write hi in my text file, I can just write, and then if I have a string, say hi, I can write it as write a. Okay, but is writing just this enough? Not really. So, as you recall, when we were reading files, we needed to open them using the f is equal to open, or whatever variable name you wish to use is equal to open, um, then in parentheses the file name. Similarly, here we need to mention where it is that we wish to write. So, if let's say I have some file called f is equal to open hello.txt, comma r, and I write f dot write a. That should work, right? No, because now if you look carefully, we are trying to open it in read mode, whereas the function that we are trying to execute is a write function. So we would need to replace this r with a w. And now this tells the computer that open a file called hello.txt in such a way that I can write in it, and then write the value of a, which is hi, inside that file. So that's how the write and write lines function work. Now, something which is very important to remember is that the write and write lines functions, or essentially anything that is opened in W mode, overwrite the entire contents of the file. So, let's assume that I have a hypothetical paper with me, and I used a pencil to write some data onto that paper. Now, should I use the write mode to write something onto this paper? Then what it does is it essentially clears everything that was already on that paper and starts writing whatever is newly being written on it. So essentially, this paper is the file that we are talking about in this context. Okay, now the third broad type of mode that we have is the append mode. So the append mode, on the other hand, tells the user, if you wish to write on a file without changing any of the data on it, you could use me. So what the append function essentially does is it will go back to our hypothetical paper and it will start writing at the end of that paper. So the original content is unchanged while the new content is added onto it, which is um, the file that we have in this example. How do you write, how do you use the append function? Well, it's quite simple. You could just replace this W with an A, and that's it. The computer now will append it instead of writing it. Okay, moving on. Let's talk about binary files now. But before we talk about them, allow me to propose an idea. It is a extremely simplified example of what we are going to look at now, but this is something that really helps people keep track of how binary files function. So let's assume I have a factory, or let's call it a warehouse. So this is my warehouse, and I have a truck which comes in to that warehouse carrying a lot of supplies, and it just throws them on here. So we have this huge pile. So the truck essentially is dumping the content that it has in this warehouse. And let's say I have another truck which leaves this warehouse. And this truck loads the content onto itself and then takes it. And this is a part where I have no objects to load. This is the part where the objects are stored for it to be loaded. And this is the place where it's all dumped. Now, might I propose to you that let's think of this dump of data essentially being the data that I want to be written in a binary file, and this neat load of data something that I want to take out of the binary file to process. Okay, now let's keep that at the back of our head and move to the main topic. We'll come back to this later. So the way binary files function in context of the read and writing part of it, we use something called the pickle function. Essentially, what the pickle function does is it's used to convert Python objects into byte streams, which are zeros and ones, or vice versa. How does this work? Well, to use the pickle function, first of all, we need to use an import statement. So I say import pickle. I tell the computer that to use this pickle module, you need to import it only then because it is not a built-in function like print statements that we have. Okay, I imported pickle, but how does the computer tell what is to be converted to zeros and ones and from ones and zeros to readable material? Well, for that we have, so the pickle function essentially can be divided into two types. The first is pickling, and the second is unpickling. Okay, if you see a pickle, it's a mush of some sauces, some vegetables. It's essentially a mix of things. You can't really make out what is in that. And that is exactly what the pickling function does. It takes in readable data, mushes it into zeros and ones. So what the what pickling does essentially, I beg your pardon, is it takes in Python objects and converts them into byte streams, which are essentially zeros and ones. Whereas unpickling, on the other hand, converts zeros and ones, so byte stream, back to Python objects. Now, the way they do this is pickling is done by a function called dump, whereas unpickling is done by something called load. So, coming back to the example that we were talking about earlier, let's say that my truck comes in with some neat human readable data. What this truck does is it dumps all of it into a big pile of zeros and ones, which is not readable to us. So essentially, it's dumping it, it's putting it all in a way that you cannot really understand it. So that's what our pickle function does by using dump. And now let's say that I want to read that data. Then what happens is that huge dump is converted by the load function. So ideally, the load will convert that zeros and ones back into the original values that we had given to the computer. Okay, I hope this example helps you visualize, and whenever you're confused between what the load and dump does, you can think of this. So the dump function will dump everything from human readable to zeros and ones, and the load will essentially load it back to human readable. So from the dump, it loads it to human readable format. So that's the difference between pickling, unpickling, and we do that by dump and load. Okay, so first let's talk about the dump function. And I'm going to leave this example over here because we're going to need to come back to it shortly, right? So the way the dump function works is first we import this pickle, and now I need to open some file. So I say f is equal to open, let's say um, test file dot txt comma w. There are two things wrong with that statement. Let's try and break it down. First, I am trying to open a text file. But remember, binary files, as we discussed in the first video, have the extensions of .bin or .dat. So this .txt will not be compatible with a binary type operation. So I'll just rename this to bin. The second, I'm trying to open it in the W mode, but as we saw earlier, whenever you use binary, you need to add a B after the letter. So WB, write binary. That's what's that's what's the correct mode to open it in. Okay, so I imported the module, I opened the file. What next? Well, we need to dump something. So let's assume I have a string called a is equal to this is human readable, and I want to convert this into binary and store it in my binary file. How do I do that? Well, the way I do that is by telling our pickle function that, hey pickle, I need to dump something into this file. So dump it in zeros and ones format, so byte stream format. So I say pickle dot dump, then I open my parenthesis. So the way the dump function works, the syntax of the dump function essentially is pickle dot dump object to write file handle of open file. Now, this is just fancy jargon which can be replaced with pickle.dump, and as I like to call it for simplicity, what to write, comma, where to write. So what that means is if if I want to write this A on into my file which is opened by the file handle F, I'll write pickle.dump A comma F. So what to write, where to write. So now what the computer understands is okay, so I need to pickle something, dump it in binary format, and what I need to dump is this A. Where I need to dump it is in the file handle open with F. Right. This is how the pickle.dump function works. But let's say I do not have a string. I have some type of list or a tuple or a dictionary or other variables. Well, variable type, data types. Yes, the dump function accepts those as well. So there's a wide variety of what the dump function accepts, but there are some limitations on it as well. Most of the time, when you use the dump function, you could use boolean, strings, tuples, complex literals. It won't give you a problem. So you don't need to worry about that. Okay, let's now talk about the load function of how I can get this dump converted into something that I can read. But before that, I want to add something to my um, far-fetched example. Let's say I have this data that I want loaded onto this truck. The issue is now that my truck driver, who is loading that data, doesn't know where to stop. So let's say he adds this. He's added all of this data onto the truck. But now he comes back and is trying to add more things to my truck, more data to my truck, essentially. But there is no data here. So he finds nothing. And then he raises an issue with his supervisor saying, hey, I tried to load the data, but there's nothing here for me to load anymore. And that is one drawback of the load function. So let's say I have some file with some data in binary format. The load function is trying to convert that into human readable format. The issue is, let's say it converts the first line, the second line, the third line, then the last line. It comes back again to this file, but there's nothing left to convert into human readable format. So it raises an error, it raises an exception, and that is called the EOF error, which stands for end of file error. So how do we combat this? Well, we could say keep trying to add the data until you encounter this and then stop. So try. When there's nothing left to try, stop. That is exactly what we need for the load function. So for the load function to work, let me quickly erase this part of the example because I think the dump function is pretty straightforward. Okay, so what we essentially said is try and keep trying, except you except if something goes wrong, then stop. So what I am going to do, let me propose, is I open my file, f is equal to open, and let's say I go back to my old example, f is equal to open test file dot bin comma RB for read binary. And then I tell the computer, try to load that data unless you encounter an error. With so I have this file open and I say try f1 is equal to pickle dot load f. Again, f1 here is just some variable that I created. It could be anything. It could be cat, dog, car, doesn't matter. As long as it's not an invalid variable name, it's accepted. Okay, so I say try loading that, and then I could have some statements there that I want to execute along with it. It does not matter. And then I say except you reach the end of the file. So you reach the end of file error. If that comes up, so except EOF error, then just stop loading. So close the file. So I'll just say f dot close. So what I essentially converted from a diagram to text is this. Keep loading the data as long as it's there. But the moment there is nothing left to load, stop this process. So when you encounter the no more data or the end of file error, stop loading. So this is how our load function works. Okay, it was a lot of information, and I am sure that there are some questions that you will have. Now is a good time to pause this video and recap everything that was said and make your own notes. Moving on, let me introduce to you a new topic. Let's say that you are walking on a new in a new neighborhood, for example. You do not know where a particular thing is and you're looking for a restaurant. So let's say you are in an unknown neighborhood looking for a restaurant and your Google Maps or Apple Maps is not working. So what would you do? Well, you would probably go and ask someone, where is this place? Where's this restaurant? And they would point and say, oh, it's there. So go there and you'll find it. So what he did is he pointed in the direction of the restaurant. And that is exactly what we are going to discuss now. We are going to discuss pointers. So, with respect to our topic, what exactly is a pointer? A pointer tells the current position in a file where the reading or writing will take place. So what that means is similar to someone pointing to where the restaurant is. This file pointer will point to the position in the file where the reading or the writing will take place from. Okay, so it is a pretty straightforward topic and we will talk about it more. But for now, let's step back for a moment to our read, write, and append modes and think. When I open my file in write mode, everything that was originally there in the file is replaced with the new data. So can I say that when I open a file in write mode, the pointer is at the start of the file. So it tells the computer that, go to the start of the file and change everything from there. So for my write function, the pointer is at the start of the file. And then let's think about our append function. In our append function, it adds everything to the end of the file. It does not change the pre-existing data. So my append function essentially has its file pointer at the end of the file. So it tells, I'm going to point to the end of the file, and that is where you start appending the new data from. Okay. What about the read function? Well, since when we use the read function, the first operation of the read lines or read line starts from the beginning of the file, we can say that the read and write functions have their file pointers set to the start of the file. Okay, now let's talk about how we, the user, the programmer, can find out where the pointer is. Let's say that I want to let's go back to the for example of someone pointing. So when I ask the person a question, they point and tell me that, there is the restaurant. They're telling me where the restaurant is. So we use the tell function. So this will tell me where the file pointer is at a particular in a particular file where the operation of reading or writing will take place. And well, it's difficult to bring this back to the example, but let's say that once I find out where the pointer is, I need to seek it out if I want to make changes. So if I want to make changes to the position of the pointer, then I'll seek the pointer. I'll tell the pointer where to go. Not a great example, but it's one way to remember it. So my tell function will tell me the position of the pointer from where the reading or writing takes place. And my seek function will change the position of it by placing it where I want. Okay, now let's talk about the syntax of how you can do this. So essentially, if I have a file open as f is equal to open and whatever the file is, and I tell and then I use the tell function, I'll essentially write f dot tell. So what this will do is it will tell me the position of the file pointer at that particular time in the file. Okay. What if I want to change the position of that file pointer? Well, then we'll use the seek function. And the way the seek function works is you write, again, we need to refer to where the file is open. So we write f dot seek. Now, unlike the tell where we can leave the parenthesis blank, the seek function needs something in the parenthesis. And what is that? Well, that is firstly the offset, and then the mode. What do I mean offset and mode? Well, offset essentially means the change that you want taking place in the position. So that's the number by which you want to move the file pointer to the left, to the right. And the mode tells so the mode will essentially tell the computer with what respect the offset should be. So with reference to what the um, moving needs to take place. So let's say I want to move the pointer 20, 20 bits to the um, left or right. Let's take right. So then I'll say f dot seek 20. But by default, when I just leave it as 20 and I do not add a mode, the file, so the seek function assumes that you mean 20 from the start of the file. So what I need to do is I need to put a mode. And unfortunately, there isn't really a good example I could give you on the mode. So I'm just gonna give it straight up. So we have three modes, 0, 1, and 2. So when I say 0, or if I just leave it blank and I don't put any mode, it means from the start of the file. So with respect to the start of the file, you want to make that change. Whereas 1 uh, being used as a mode tells the seek function that the change needs to take place from the current position where the file pointer is. And 2 tells the seek function that the change needs to take place with respect to the end of the file. Okay, so like I was saying, if I wanted it to be moved 20 from the current position in the file, I'll write it as 20, comma 1. But let's say I want it to be moved 20 back from the end of the file. I'd write f dot seek minus 20, comma 2. So you're telling the computer go back 20 from the end of the file. So this is how the seek and tell functions work. All right. This was about binary files. Moving on to the last topic in this file handling sequence that we have. Let's say, so all of us are familiar with Google Sheets, Microsoft Excel, and all these other um, softwares which process large quantities of data in tabular format. So it makes life really easy for us. So let's assume that I have some table here. Let's assume that I have some table here and it has a large amount of data that I need to store, share, perform actions on, whatever. But if I keep trying to, share it as a table in the traditional sense of a table that we have, it's not that easy. So what I can do is, might I suggest that what I can do is break this down, into individual elements, store them as a small file with considerably less space, share them, use them, and do whatever I want with them. So what I'm saying is, let's say I have some data, name, age, and favorite color. So let's say I have John, aged 53, and the favorite color is blue. I have Sonia, age 25, favorite color is black. I have Rahul, aged 40, favorite color blue again. And let's say lastly I have Jack, aged 8, favorite color orange. So let's break this down into easily shareable data. So let's break this down. Let's say that so the advantage of a table is that we have columns and we have rows, and that helps us segregate them easily. Let me break this down as name, comma, age, comma, favorite color. That's the first one. Then I have John, comma, 53, comma, blue, and then so on and so forth, with each thing being separated by a comma. So here, a comma is the thing that's separating. So it's a comma separated value. And that's exactly what we use when we want to convert data in tabular format. We use an extension called .csv, comma separated value file, .csv file. So everything is separated by commas. Now, of course, it would not exactly be written like this. We would have um, quotation marks everywhere to indicate string, and then there are certain rules that it needs to follow to distinguish between different lines and individual elements in a line. So to sum it up, the advantage of using CSV files is that a large amount of data can be stored easily. It is a preferred format for export or import of data, and it's easy to create. Okay, so I have pitched to you the idea of CSV files, why they're so good, so on and so forth. How do you use them? Let's say you want to create a CSV file. How would you do that? Well, to do that, just like Pickle, we need a module called CSV, which will tell the computer how it can do that. So the first thing with CSV as binary files, we need to import that CSV module. So import CSV. Okay, I've imported CSV. Now what? Well, to write CSV files, I need something to convert data from normal data into CSV data. Why? Why can I simply not just use write functions? Well, CSV files essentially, as we saw in the previous examples, was separated with commas. But let's say my data itself contains a comma in it. How is that evaluated? Well, that is where we use this conversion tool, to put it crudely. It ensures that the CSV data that is being given is uniform, standardized. It converts it into a particular set, it converts it into correct form of CSV data, which can then be used wherever it has to be used with whichever software. So for that, we use something called a CSV.writer function. And what this does is it stores data as a list or a tuple, stores data as a list or tuple, and converts it into the correct delimited form. So remember, like we discussed in the first video, anything can be a delimiter. It could be a hash symbol, it could be a dollar symbol, it could be a backslash symbol. Of course, it needs to be created in that way. But yes, this CSV.writer ensures that the data is converted to the correct delimited format. Okay, how do you use this? Well, to use this, we need to once again create a writer object which we will reference when we want to use this CSV.writer. So let me call it, for simplicity, let me call it fwriter is equal to CSV.writer. But I'm missing something. Where should CSV writer work? Where should the CSV writer work? Well, we need to tell it where it's supposed to convert and insert that data. So if I have some file open with f is equal to open, so on and so forth, I need to write fwriter is equal to csv.writer f. So now it knows where to insert the data when it is called, when it's being used to write rows of information. I also mentioned that we can choose the delimited form. How would we do that? Well, don't worry, the syntax takes care of that as well for you. So by default, if I leave it as csv.writer and in parentheses the file handle, then it assumes that you are referring to a comma separated value file, the delimiter being comma by default. However, I can specify what delimiter I want by writing comma, delimiter is equal to, let's say, a dollar symbol. So now instead of a comma, my data will have a dollar symbol in between values. But for simplicity, as we are learning this concept, let's just assume that the question was set by someone who is a good person at heart. They just want simple commas. Okay. How do I write? Well, write functions normally tend to stay the same with write being a part of it. Um, but yeah, since we are writing, since we have a table that we need written, we essentially want to write the rows in that table. So we will use something called write row for single rows and write rows for multiple rows or the entire data that we want to put if we wish to insert it at once. Now, an important thing to remember is that when we use the right row and right rows, right row will enter only one row of information, as the name suggests. So if you were to insert multiple items, you would need to probably call a loop. So let's look at an example with the right row function first. So the first thing I would need to do is use import CSV to call the CSV module to use it. And then I'll say f is equal to open some new file, or let's take a creative name this time. Let's say open a cat file dot csv comma w to write. Now I need to call my writer object to convert it in the correct format. So now I'll use fwriter, or let's just call it cat writer. Cat writer is equal to csv dot writer and in parentheses f, which is the file name where I want it to be written. Okay, I did that. Now, let's say we want to write the original example that we discussed with the name, age, and favorite color. So let me add a heading row over there. So I'll write, let's say that my heading row is saved in a variable called h, which is a list with the first item in that list being name, comma. So name is in string format. It has a single quotation around it. Name, comma, age, comma, favorite color. This is in a list format. And now what I'll do is I'll write fwriter dot write row h. Or to save time, I could simply write fwriter dot write row and put in this list within the parenthesis and close the parenthesis. That does the same thing. So now my file has a heading row as name, age, favorite color. Okay. Let's say I want to take in the name, age, and favorite color of 5 different people. How would I do that? We did a similar problem a while back. So let me just continue in the same indentation over here in the interest of space. So let me propose that we create a loop which will run 5 times and insert that data individually. So I'll write for I in range 0, 5. I'll first accept the name. So A is equal to input enter name. then B is equal to explicit conversion from string type to integer. So int of input enter age. C is equal to input enter favorite color. Okay, so now I have taken the values from the user. Now what? Well, we need to convert it into a list form. So I'll write, let's assume that for a row, which is basically a record in that file, I'm gonna take the shorthand rec. So rec, REC is equal to in list format A, comma B, comma C, which is essentially the same as writing individually the values. This is just replacing the values with the variable names since the variable names save that value from the user. Okay, now I have a list. So what I do next is write f writer, or since we took cat writer here, cat writer dot write row in parenthesis rec, and the same thing here as well. Instead of f writer, it'll be cat writer, whatever the variable you want to use. And once I'm done with this, I come out of the loop, f dot close. Now this is when we want to individually accept the data and upload it separately in multiple lines. Let's say I have the data with me. Let's assume now that I have the data with me in some different variable. So let's call in the import function again, import CSV, and I say f is equal to open um, duplicate file dot CSV in write mode. Let's say now that I have all the data with me. So I have a list A is equal to blah, 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 blah. It has all the elements, my heading row, my content row, everything that I could possibly want, in the which is the same as whatever we input. Let's say we have that. Well, then we will write, again, we need to call a writer object. So I'll say f writer is equal to CSV dot writer f, which is where I want it written. Okay, now what? Well, since I have all the data with me, I'll simply say, CS, so f writer dot write rows, write rows, and in the parenthesis, I'll simply write A and conclude it by writing f dot close. So what that did was it took all the data I had in A, converted it into a number of rows of data, and inserted it. So that was our write rows and write row function. Okay, so this was how you would enter data into a CSV file. Slightly complicated, but if you practice it a couple of times, then I'm sure you'll know it like the back of your hand. Okay, now let's talk about how we can read data from a CSV file. Let's talk about how we can read data from a CSV file. Well, the read function is very, very straightforward. It's basically you need a reader object, so somewhere where you store all the data. So let me assume reader is equal to CSV dot reader and the file handle, which let me assume is f is equal to open some file name in read mode. What this does, it stores all the data in f into my reader function. Now, let's say I want to go through all those items which are now in reader. Remember, this stores data in tabular format. So if I wanted to go through it one by one, I would need to iterate through the different rows in my reader. So I'll need for I in reader print I. So now it will print the individual rows that I have here. And then if I write f dot close, my program should work, right? We missed an important statement. Import. Without the import CSV statement, none of this will work since CSV is not a built-in module and needs to be called every time we wish to use it. Okay, so my reader function looks pretty simple, right? What if now I say get the data out, and now from the previous example, I want to know all the names of the people whose data I took. The way I would do that now is, well, do you think print I would work? Well, not really, because what print I does is it prints the entire row that's there. How would I do that? Now, if you remember how the data is being stored, it's being stored as a list of values. And then you can think of this as a huge list with all those mini lists which are our different rows. So let me bring back that list over here. So let's say I have name, comma, age, comma, favorite color. So this is my mini list. And then I have other values here like John, 53, blue, comma, so on and so forth. So these are mini values in my main list. So what this first I does is it goes to this reader where now the data from F has come and it iterates through the mini lists. The mini list as a whole is iterated through. So when I say print I, what I mean is print the entire mini list that I have. Let's say now that I want to print the name. So what would I do? Well, I would tell the computer, okay, access I and then print the first thing that's there in I, which is our name. So let me go back here and make a few changes. So I'll say for I in reader, so go access my mini list in reader, which is my row, go access my row, and in my row, go to the first element. So then I'll say, so my name is equal to I at 0. Now remember, indexing in lists starts from 0, not from 1. So the name which is in the first position is technically in the 0th index. So I'm saying there's some variable name, and the value for that variable is stored in the first position of the row that I have. And then I say print name. Now you could technically have written this simply as print I at 0. Now that's your preference on how you wish to do it, but there are ways to do everything simply. I'm just writing it in multiple steps to make it clearer for everyone. Okay, now let me ask you, if I wanted to check if I have the color blue, or let's count the number of people who put their favorite color as blue. How would I do that? Think about it for a second and then pause this video, think about it and try it. Now, the way I would do that is I have a method here to check how many, I mean, to print the name of uh, the people who are there. Let me Let me propose that we create a counter first of all to keep track of how many people like the color blue. So let me just write B is equal to 0, as in B is equal to 0 before we count it, because we need to start counting. Okay, now what? Well, let me go back here and say, so now we are in this reader. So let me just create, let's just go back to that list. So let's say I have John 53 blue, then I have Rahul 25 red, then I have Joseph 39 blue again. And that's the end of my list. So let's say that is what I have. Now the way I want to execute is that I want to say, okay, first go to my row, go to my row, go to my row. So I have rows. So go to my row and then go to the third value there, which stores the color which I want to check for. So what I'm going to do is I'm going to say for I in reader, which is basically where this data is stored. So where all my rows are stored. So for I, which is for a particular row in this data that you have, go to the third place. So I'll say color is equal to I at 3 because it's in the third value position, right? No. Once again, remember indexing starts from 0. So it'll be name, age, color. So it is 0, 1, 2. So I at 2 is where my color is saved. Now I want to check if it's blue. So I'll write if color double equals to blue, B is equal to B plus 1. So initially it's 0. If it finds the color blue, then just increment the value of B by 1. And once all that's done, print number of times blue appeared, comma B, f dot close. So this basically will check for for the number of times the color blue appears. Now there are multiple versions, ways you can play around with this to check for different values, check for the number of vowels, consonants, find something particular over here. But this was a broad overview of the chapter file handling. So we will go over some questions as well, which I feel are important. And yeah, that's the chapter.